All right, good morning, learners, and welcome to today's lesson. Unfortunately, yesterday I couldn't get in because of this loose setting thing, but I hope I will make it up to you. So today we are going to look at forces, and our subtopic will be gravitational forces. You remember last time we were looking at contact forces and then field forces. So gravitational forces or gravitational force is one of the what? Field forces. Okay, so our lesson objectives for today is that by the end of this lesson, you should be able to explain that a field force results from an action at a distance between two bodies. Describe the force of gravity. Explain that objects with greater mass have more gravitational pull on each other, meaning the greater the mass, the greater the what, the force of gravity or the force of gravitational pull. Explain that force decreases as distance between the objects increases. So meaning here, force is inversely proportional to the distance. You should be able to state the unit of measurement of gravity, and at least you should be able to state four differences between weight and mass. Okay, so as a way of introduction, the last time we were looking at what contact and field forces. So a contact, what is the main difference between a contact force and a field force? So we can say that a contact force exerted when two objects are in contact, or if you want to say touch each other, while a field force is at a distance. Okay, now let's look at gravitational force and then a field force. A field force is exerted by one object on another object without the objects touching each other. Sorry. Gravitational force is a pulling force that bodies exert on each other over a distance due to their what? Masses. All matter has what? Mass. You remember we looked at matter somewhere in the previous grade. So all matter has mass. Gravitational forces act in a gravitational field. And gravitational force also works in pairs. You remember at contact force, a typical example was when we are pushing an object, the object tends to push back. So here you are having what they are working in pairs. So the force that you are exerted on the body, and the body is also exerting a what? The force back, but equal but in opposite what? Direction. Okay. Then the Earth exerts a gravitational force on all matter. So you know that we have got other objects that are on the surface of the Earth. So meaning the Earth is having a kind of gravity, and then this gravity is exerted on all matter. There is a gravitational force between the Earth and the Moon, and between the Earth and the Sun. The size of gravitational force depends on the mass of the two objects and the distance between the two masses. And then we show what the differences between mass and then weight. All right. Now let's look at field forces. So a typical example of a field force is a gravitational force. So we just looked at that. Now a field force is exerted by one object on another object without the objects touching. So we have seen that gravitational force is a pulling force that bodies exert on each other over a distance due to their masses. So not only is there a gravitational force between the Earth and the Moon, but also between the Earth and the Sun. So it means there is a relationship, a force relationship between the Earth and the Moon, the Earth and the Sun. So that's why they are in orbit. Okay. All matter has masses, so that's just what we said. So here we can say that there is a gravitational force between all matter on Earth and planet Earth itself. Force that causes object to fall directly downwards. That's why, for example, because all matter has mass, that is why when you throw an object up, the object doesn't continue flying forever. You see that it comes down. That's why they say any object flies up will what surely come down. So it's because of what this gravitational force. So I repeat point D, all matter has what mass. There is a gravitational force between all matter on Earth and planet Earth itself. It is this force that causes object to fall directly downwards. So if you are asked, hey, why is it that objects, when you throw an object up, it comes down? So you can simply say it is the earth force or the force of gravity that pulls or that causes object to fall directly downwards. Okay. Forces act in a gravitational field. So just as we are having magnetic field, so do we have what gravitational forces or gravitational field. So the previous slides also say that gravitational force works in pairs. That's true. So the size of gravitational force depends on the mass of the two objects and the distance between the two masses. Okay, so uh, here you will be talking when you go to grade, I think somewhere in grade 11, you'll be doing what Newton's law of gravitation, universal gravitation. That is, so this G is talking about that. So what this law says that if you have got two masses, their masses are directly proportional. The force of the masses are directly proportional. So it means when the mass is increasing, it means the force is also increasing. But the same force is inversely proportional to the what? The masses. So if the masses are far apart, then it means the force of attraction is less. So what we say is that the higher or the longer the distance, the lesser the force of attraction. But on the contrary, if the forces or if the objects are close to each other, then the force of attraction is quite high. So it means the shorter the distance, the what, the greater the force. And the what, the longer the distance, the what, the less the force. All right. Now, there are several differences between weight and mass. So let's just look at them. Mass is a measure of the quantity of matter in an object. So mass, what is mass? Is a measure of the quantity of matter in an object, while weight is a measure of the size or force of gravity acting on the mass of an object. So mass is measured in what? Kilograms, while weight is measured in newtons. The mass of an object is the same anywhere in the universe, while the weight is different in different places in the what universe. So here, let me repeat this point again. Mass of an object is the same anywhere in the universe, while weight is different at different places in the universe. So here, what it means is that if me, who is teaching or talking to you right now, I have a mass of what, 75 gram or kilogram, then I happen to move to space, my mass is still going to be the same thing, it's the same everywhere. But then my weight is going to be different. And why is my weight going to be different? It's going to be different because of what? Acceleration due to gravity or the gravity. So the gravitational force on the moon, on the earth or moon or wherever is different from that of the earth. So take note. So you have the same mass, but the force of gravity also determines your weight. So it's the same person on earth. If I'm 75 kilogram, then I go to space, I'm still going to be the same thing, but then my weight is going to be what? Different. So another way of saying is that mass is constant while weight vary. Okay, the mass of an object does not depend on the size of the gravitational force, while the weight of an object depends on what? The size of the gravitational force on it. Okay, now this is a table looking or trying to summarize the differences between mass and weight. So take note of this. Even in grade 10 is going to be the same thing, in grade 12 is going to be the same thing, and upwards. So if you are asked to tabulate two differences, or you should differentiate using a table, this is what you can do. So one way of differentiating is to give the definitions. So you can see that if they say differentiate between mass and weight, so one, you can use their definitions. Two, you can use their unit, the SI units of measurement. Three, you can look at whether they are constant or not, and then the magnitude or size of the object. Okay, so here we are talking about mass. So mass is a measure of the quantity of matter in an object. So weight is a measure of the size of force of gravity acting on the mass of an object. Okay, guys, I hope you are listening. If you can hear me, message first. Hello, hello, guys. Are you with me? If you can hear me, send me a message. Guys, are you with me? Are you here? Okay, cool. Okay, that's great. So you are with me. Now, so tell me, what is the unit of the SI unit of measurement for mass? The SI unit of measurement for mass. So let me know if you are here. The SI unit of measurement for mass. Okay, let me quickly see. All right, kilogram. Okay, and what about the SI unit for weight? Yeah, SI unit for weight. That's good. Okay, you are listening, so we can proceed. Okay, and thanks for the response, Mylena. Let's continue. So another difference is that of which you've just mentioned, mass is measured in what kilograms and weight is measured in what newtons. So the mass of an object is the same anywhere in the universe, but the weight of an object is different in different places in the universe. The mass of an object does not depend on the size of the gravitational force. Okay, so whether if the gravitational force is big or small, it doesn't matter, so far as it can act. Yeah. So if the object is small, it means it's having mass. If the object is big, it means it's having mass. All right. It's small or not, the gravitational force still acts on it. Okay. Then we said the weight of an object depends on the size of the gravitational force. All right. So let's go on. Okay. Now let's look at what the Earth's magnetic field and how it reacts. Okay. So now the Earth attracts some objects. So meaning there is a kind of magnet in the objects or on the planet Earth. So that's what we are relating here. So if you look at it, these diagrams that you are currently seeing, and Earth has a magnetic field as though there is a big bar magnet running through the core. So you can see it. So this is how the magnet is and is able to attract the objects. Okay, and then we are also able to use it to do to also get directions. Okay, now because of the Earth magnet, that's why we are able to use the compass or the geographical these geographical materials that are able to give us direction so that we can be able to navigate. So we say in the Earth's magnetic field is the reason why we can use compass to tell what direction. The plotting compass has a needle with a small magnet. The needle points to magnetic north because the small magnet is attracted to the opposite magnetic field and can be used to determine the direction. So as you can see here, so this was what was used in the olden days. But now, because of technology, we have got different compasses, meaning high-tech ones that can give you the direction to a place. A typical example is GPS. Okay. All right, now let's go to the next. So Now, this is what we have. So when we talk of the Earth's magnetic field, and can you see this diagram? And have you heard of the southern or the northern lights before? Do you know how this phenomenon occurs? Now let's look at this. So what you are seeing now is the Earth, and then this thing is on top of the Earth. So let's see what happens. How does this color changes? Charged particles escape from the surface of the sun. So it means the sun that is above us produces what? Particles. And these particles are charged particles. Now, when we talk of charged particles are simply, they can either be positive or negative. So a charged particles are just positive or negative particles. So yeah, this sentence is saying that charged particles escape from the surface of the sun and moved upwards in all directions. So since the sun is above the earth, so when the particles are escaping, they move in all directions. And down listen, when the charged particles reach the earth, since moving in all directions, definitely some will move towards the earth. Now what happens is that some are trapped by the earth's magnetic field in areas in space around the earth's atmosphere called belt. So when the charged particles are trapped by the Earth's magnetic field in areas in space, they are called what? Belts. Is okay. It's just somebody saying something here. Let me quickly see. Quickly see. Okay. Sometimes the charged particles escape the belt and spiral along the magnetic field lines towards the magnetic poles, where they enter the Earth's atmosphere. So you see, they then interact with atmospheric gases, causing beautiful light shows. So you see, so this one are the charges interacting with the magnetic field around the poles of the earth. Okay. Now, and then this is what we call the southern light viewed from the International Space Station. Okay, so when you are out of space and you are looking at the Earth and the charged particles that from the sun and interacting with the magnetic field of the Earth, then these beautiful belts are formed. Okay, now let's go on. Sometimes the charged particles escape the belt and spiral along the magnetic field lines towards the magnetic poles, where they enter the Earth's atmosphere. They then interact with atmospheric gas particles, causing beautiful light shows. Now let's look at this. Some liquid can also become magnetized in the presence of strong magnetic field. And when they do, they are called ferrofluids. So it means some liquids that are metallic-like can be magnetized as a result of the presence of magnetic field. And when they are done, the such fluids or liquids are called ferrofluids. So a typical example is what you are seeing here. An example of a ferrofluid, that is a liquid that has become magnetized in a magnetic field. Okay, so let's go on. Okay, so now I have got some questions here, and then please, if you have a question, can you ask before we go to the assessment? So we are going to do assessment. Those who are not able to go to Kahoot with us or join us with Kahoot, then you are not left out. You will be part of this, and then before we then sign in and move to a Kahoot. So I'm quickly going to move. So please give me any question, send in any question before I move to the next slide, so that we'll just look at the questions before we move to Kahoot. Okay, guys, are you with me? And are you hearing me clear? I hope so. My learners, are you hearing me? My learners, my dear learners, are you hearing me? Okay. All right. Let's go to. Okay. Guys, hello, my learners. Sorry, I shouldn't be using guys. Hello, learners. Sorry for that. Are you here with me? Hello. All right. Hello. Hello. Okay, so let's continue. Now, so we have just looked at what field force, which is gravitational force. So the following are what illustrations of what contact forces. So here you have got this person pulling a what this big block. So which is what is there is a frictional force, and at the same time what tension force. There is tension between the rope being pulled by him, and there is friction between the block and then the floor, and there is also tension, friction between his legs or his feet, and then what the ground. Then here we have got crashing though, and then we have got what compressing a tennis ball. All right. So contact can mean to physical touch. So contact forces are forces where the body that are exerting a force on each other are in direct contact with each other. So you can see that we have got this gentleman being pulling the rope. So that is a contact force. Okay. So examples of contact force. So you have rope there and then compressing a spring. All right. Now let's look at taut. Taut or taut. Taut means stretch or pull, not slack. So a tension force is pulling force, causing it to become what taut. All right. A compression force is a force on a body that causes it to become squash. So you can see that we have got various illustrations, the compression and then the crashing. So all these are contact forces. Now these are other different forms of contact forces, but or illustrated. So we have got tension forces. It means that when you have a material and you are pulling at both ends, then compression, another illustration, when you are pushing up, okay, in. So compression is pushing in from both sides and tension is pulling out. Okay, so this is the object that is undergoing compression and then what tension. So tension forces are two forces acting on one object in opposite direction to strike the object. Compression forces are two forces acting on one object in opposite directions towards each other to compress or deform the object. There are many other examples of compression forces in everyday life. So a bridge experiences both compression and tension due to the weight of the cars and other vehicles which pass over it as shown. So if you have a bridge, have you noticed a bridge in which the, the road seems to sag a bit or bend a bit? And because of pressure and other things, the bridge is experiencing compression and tension at the same time. So when the objects that are on the road, when they are carrying more load, the bridge experiences compression. At the same time as it is experiencing compression, it is also what experiencing tension. Okay, so when we have been looking at contact forces, which include friction, normal, and compression and tension, we are now going to look at forces that act between objects which do not touch each other. So now these are all representation of what friction. They are objects that touch that what contact or are in touch with each other. But the previous ones that we looked at, which is gravitation, they are forces that do not touch each other. All right. Then we have got what advantages of friction and what disadvantages of friction. So the advantages of friction are that it is used in brakes to slow down and to stop a car. And the friction of a match against a matchbox causes the match to ignite. The main advantages of friction are that it produces unnecessary heat in machinery, and that it slows down the motion of moving objects. Okay. Now, so basically, I was just reminding you of those ones that we have looked at. Now we're continuing with the field forces. As you can see here, we have got this got some people here. So field forces are the result of what an attracting or repelling force of one object on another object without objects touching each other. Examples of what field forces are gravitational force, magnetic force, and then electrostatic force. So see, so this is the Earth. So the arrows are showing that we have got what? A gravitational field of the Earth. So the arrows all point towards the center of the Earth because the gravitational force is always attractive. So you listen. Gravitational force is always attractive. So that's why the arrows are pointing to the Earth's surface. Now let's look at this. The Earth attracts us because it has what? Such a large mass. They are attracted downwards towards the center of the earth all the time. So look at these people, these skydivers, these army skydivers have just jumped out of the back of a plane and fall towards the earth due to what? Gravity. Okay. Now, so uh, look at the interrelationship or interaction between the field forces. Now you see the sun, you have the earth here. So we were told that the earth is releasing some charges. So as it releases the charges and it's going to the earth, they interact with the magnetic field, and then we will get what that beautiful bells that are formed. Okay. So these are the 9 planets. Okay. As we know from the planet Earth and beyond, all planets solar system are held in orbit around the sun by the gravitational force of attraction between the sun and the planet. So you see, this is the sun, and surrounding the sun are the what? The other uh, planets. Now the planets move around the sun in our solar system. There is a gravitational force of attraction between the sun and the what planet, and between planets and their moons. Very good. All right. So this is what we're talking about. So now this is just a summary, but I want us to quickly go to our Kahoot, and then, but guys, do you have any question? Do you have any question? Do you have any question, guys? Hello. Okay. Um, I'm quickly going to move to Kahoot. Uncle, you want to ask privately? Hey guys, can you see the Kahoot? My learners, can you see the Kahoot? Can you see the Kahoot? You can see it. Can you see? Okay. Let me just try to share again. Can you see? Can you see now? Can you see now? Okay, I can see Kincaid, Oreo, Daisy. Okay. All right. Who are those who cannot join? Okay. Tabitha, Onka, Kincaid, Oreo, Daisy. Let's join. Let's wait for one or two to join before we can play. The time is going. Okay, then they will join us later. So let's go. Okay, so let's go on. True or false? We can see falses. True or false? Can we see falses? All right, so let's see. 4 people answered this right and then 1 wrong. So let's see those who, yeah, okay. So 4 people answered correctly, but the one who did answer first is Onka, followed by Oreo, Kincaid, and Daisy. If you are ready, let's go to the next question. Which kind of examples are contact forces? All right, so let's see. So, so this friction is contact force. Three people got this one right. And then let's see. Okay, all right. Oreo, uh, three people, but Oreo was the first person, followed by K, Kim K, and then Daisy. Max, and then Max, followed by Max Daisy. All right, didn't answer this time around, or you got it wrong. Let's go. The two forces acting on a rocket as it blasts off. Let's go on. Okay, so these are the two. Okay, all right. Only one person got this one right. That's thrust and gravity. So let's see who got that one correct. Who is this person? Yes, it's Kim K. So Kim K is leading on the scoreboard. Let's go to the next. Forces can be, forces can be, forces can be. All right. All of you got this one right. Let's see who got it first. Let's see. Yes. Okay. So, but King was the first person to, followed by Oreo, Onka, Daisy, and Max. Let's go to the next. Name two forces. Name the two forces. Okay. Three people got this one right. Let's see. And one wrong. Who are those? Okay. Uh, K was the first person, followed by Onka and then Max. Okay. Now let's go to the next. Let's go to the next. Okay, so this one is coming again. Name the two forces. If you who didn't get it, you can get it now. Those of you who didn't get this question, you are supposed to get it now. All right. One person still got it wrong. All right. Let's see whether there is improvement. Okay, still K followed by Onka, Oreo, and Max. Let's have fun. Let's go on again. Gravity is a force that pushes up. True or false? Gravity is a force that pushes up. True or false? Yes, the clock is ticking. Let's see who are those. Okay, so we have five. Three people got this one right and one wrong, and the other one did not answer. So let's see the one who got it. Okay. Yeah, K was the first person, followed by Max. Max has improved, followed by Oreo 39. Let's go to the next and see which of these examples are contact forces. This is also repeating again. Those of you who got it wrong, try to answer it. Yeah, those who got it, there we go. Yeah, how? One person got it right and three wrong. Let me see this person who got it Oreo. You see, the same question came up. You see, the first time three people or four people got it right, but this time around it repeated and one person got it. Guys, you must be observant. I intentionally did it this way so that we can see. Let's go on. Scientists measure forces in what? The sticky. Select or choose your answer. Very good. Yeah. Three people got this, and let me see who are those. K, Oreo, and Max. Who? All right, let's go on. What is an important difference between electric and gravitational force? Okay, two people got this right, and then one person answered gravitational force attractive for gravitational force attractive or repulsive, which is wrong, and another one gravitational is less than electric. So let's see the two people who got this one right, which is gravitational force only attractive, and electric force is either attractive or repulsive. Let's see this person. Okay, all right. Hey, and then which what is or are magnetic forces? Perfect. Three people got this right. Let me see who are those. Okay. Uh, K, Max, and Oreo. Let's go to the next. Okay, forces that act between objects that are in contact in equal and opposite forces are. All right, great. Somebody got four people answered, three got it right, one wrong. Let's see the scoreboard now. So Oreo got 8 out of 12. Max got 8 out of 12. And K got 10 out of 12. Okay, let's let's go to the next and see what happens. Okay, so in all we have got what four difficult questions practice. So let's get the feedback before we move out of here. Okay, let's look at the full report. View full report. Okay, I hope you guys enjoy it. So we are viewing the full report, and after our lesson is ended. Okay, let's see what the report is saying. Practice makes perfect. We have got 38%. In all, we got 38% correct. Then our time, okay, those of you who need assistance, who need help, I mean, is Tabitha, James, and Daisy. But I saw only Daisy. Okay, all right. Then those of you who didn't finish, Onka, you didn't finish, Daisy, you didn't finish, Tabitha, okay, you didn't also finish. All right, next time try to finish. All right, I hope it was a nice lesson. Enjoy the rest of your day, guys, and see you tomorrow.